one little bit of intriguing historical information. You may not know this. She knows everything about the subject. You may not know this. In 1931, when H.B. Churchill, the chief chemist for Alcoa, found that the cause of dental fluorosis was fluoride in the drinking water, he quietly called the dentists near aluminum smelters, including Messina, New York, and found out that kids there had dental fluorosis, but the levels of fluoride in the water was practically zero. So they knew in 1931 that their fluoride emissions from their plants would produce these telltale markers of dental fluorosis in the children. And so you could, if the kid comes down with dental fluorosis, oh, that's caused by fluoride. Well, where's the fluoride coming from? Oh, there's an aluminum smelter. You can see that will be you can see how it would scare the pants off these industries to have those telltale markers. Now, I'm going to jump a little bit further. I shouldn't do this, but let me jump a little bit further and say, therefore, if you're in the industry, how far-fetched is it to think, well, one way to protect ourselves is to make sure many children have dental fluorosis. Many children have dental fluorosis by putting it in the drinking water. Because then you have so many kids with dental fluorosis. No one would say, where is it coming from? I see an aluminum smelter on it. No, it's coming from your water. It's coming from your toothpaste. So I don't know if that's the case, but it's an interesting conjecture. Yes. Is there anybody else? You're wonderful questions, right? We have to rate somebody like you as a company, but is there anybody else? Yes. Okay.
How do you personally avoid fluoride?
We avoided fluoridation by busting our butts to get it out of our water supply. So you cannot protect yourself very easily. I mean, yes, okay, what we did for 7.5 years before we got it out of our village was to go and buy these 5-gallon blue jugs of bottled water with the towel. So we used that water for drinking and cooking. But we couldn't protect ourselves from the shower, from the bath. My wife was fed up because she's watering the garden with fluoridated water, and she's a very clean, organic gardener. Every time we have a cup of tea, cup of coffee, glass of water downtown, any restaurant, we're getting fluoride. Every time I go to walk and drink coffee, I'm getting fluoridated water. And every time you go to a friend's house, you're getting fluoridated water. So you can't protect yourself by simply protect your tap. And so really the best thing to do, rather than spend thousands of dollars on reverse osmosis or hundreds of dollars on reverse osmosis or bottled water, work with this group and get it out of Toronto. Finish it worldwide. Finish it. End it. That's the best approach to protect yourself. Probably not what you wanted to hear, but that is definitely the best approach. Anybody else? Yes. I'm going to come back to you. I promise you.
Two questions. Fluoride is a chemical compound. Is it the same compound on the world, or are there differences that will impact its effect?
It's that, they come up all the time. When a compound dissolves in water that contains fluoride, the fluoride goes one way and the other ions go another way. So you put sodium fluoride into water. It's essentially two chemicals. The sodium ions floating away in water and the fluoride ions floating in water. If you take another one, say you take magnesium fluoride, put that in water. The magnesium ions go that way, the fluoride ions go that way. So essentially, once you're dealing with the fluoride ion, it's the fluoride ion. Okay. Now, what are the differences? What are the key differences? Well, number one, when you have natural fluoride, it usually comes with high concentrations of other ions, like calcium, from other rocks. You get high calcium fluoride, you get other calcium. So it may be that calcium is partially protected against fluoride. Another issue is solubility. Some people have misjudged this. Calcium fluoride is less toxic than sodium fluoride. Why? Because calcium fluoride is less soluble than sodium fluoride. Sodium fluoride is very soluble. You get 1 gram of sodium fluoride, it dissolves in water. It's all fluoride. half of it is fluoride. Calcium fluoride, if you put 1 gram in water, most of it wouldn't dissolve. And it's what's in solution that's basically going to hurt you, not what's outside. If something's insoluble, it goes straight through into the feces, out. So it's complicated. Now, there's another complication, and that is that when you're dealing with industrial grade chemicals, as in the case of these silicon, you're not getting pure chemicals. You're getting all the other junk that's produced when you heat phosphate rock up with sulfuric acid. You're getting arsenic. You're getting lead. And even the rock that they mine in Florida is the same rock that they mine for uranium. One way you go for fluoridating chemicals for water fluoridation, the way you go for uranium. And so there are trace amounts of radioactive isotopes in this thing. And then we get into a whole long discussion about after you've diluted the stuff 180,000 to 1, is all the hexafluorosilicic acid dissociated into free fluoride ion, and therefore you can treat it like a solution of sodium fluoride, or is some of it still associated? One question. The other question is, by the time you've diluted the 1 part per million by 180,000 to 1, is all the arsenic below regulatory standards. Let me take the last one first. The maximum contaminant level goal for arsenic in the United States is 0. Because arsenic is a known human carcinogen. So the ideal goal for a water level for arsenic is 0. However, the standard, the enforceable standard, is 10 parts per billion. Because you have to strike a compromise between the ideal to protect health and the cost of removing the arsenic. So when they say, oh, well, we've looked at the arsenic levels after dilution and it's less than 1 part per billion and the standard is 10 parts per billion, they are misapplying what is happening here. It's one thing to say, we're going to have to set the regulatory standard for 10 parts per billion because of how much it costs to remove arsenic. And the other situation where the ideal is 0 and you are consciously adding arsenic to the water because you're adding these contaminated fluoridated chemicals. The latter is illegitimate. The ideal is 0 and you shouldn't be consciously adding these fluoridated chemicals. What you're doing is you are definitely increasing the risk of cancer from arsenic by putting any arsenic in the water. And lastly is the priority dissociation. They will cite a study done at the University of Michigan which showed that with dilution the dissociation of hexafluorosilicic acid was complete. However, that same study showed that if you lower the pH, if you make the solution more acid, when you got down to a pH 3, there were 5 fluoride ions still attached to the silica. So the question, so in acid, the silica, the hydrated silica and the fluoride recombine. So what happens when this silica and fluoride go into carbonated beverages, which are acidic? Do they recombine? What happens when you're drinking water which has both hydrated silica and fluoride and it hits your stomach at pH 1 to 2? They would immediately recombine, and we're back to the notion of having this silicon fluoride complex, which at least Masters and Copeland believe it increases the uptake of lead into babies' bloodstream. And in fact, it was a study published this year by Sewan, who did an animal study to test this thesis of Masters and Copeland, that hexafluorosilicic acid increases the uptake of lead into children's blood. And in rats, he gave the rats lead, he gave the rats hexafluorosilicic acid, and he gave the rats lead and hexafluorosilicic acid together. And the rats that got the lead and the hexafluorosilicic acid had more lead in their blood and more lead in their teeth. So they felt that they had vindicated Martin's approval with this animal stuff. So it's a simple question, but you see it's a convoluted answer. Yes, Alice.
I just want to announce that Dan Summers is a celebrity who's totally on board in fluoridation.
Yes.
John Travolta is, but he's a little bit busy right now because he's preparing for the birth of his child. And
Martin Sheen.
Martin Sheen, although
His wife, probably.
and
Ed Asner signed the back of his book.
and Bob Barlow, very close.
Yeah. And I'm going to Los Angeles and to Malibu, and I hope to be signing books in the bookstore of some of these stars, and hopefully we'll get a few more stars. But yeah, just a couple of years back, they suddenly fluoridated the water of the metropolitan district, which covers practically the whole of Southern California below Los Angeles, and that included Hollywood, Malibu, and so on. So all of a sudden, all these film stars and famous people suddenly are getting fluoride, and quite a number of them have responded appropriately to this challenge. And I hope we get a few more. Yes, okay. 1, 2, 3. How about that? 1, 2, 3. Unfortunately, I've only got the one. It will be available in Canada. In Canada, there's a different publisher. It's I think they use the University of Toronto Press. What's the name of the publisher? Indigo? Anyway, it will be available on the 18th when I get back. October the 18th, watch out. Get Karen Buck's telephone number, email. She will tell you where that meeting is going to be. The University of Toronto bookstore is going to be providing a whole bunch of books which I can sign and sell to people on the 18th. Here, October 18th in Toronto.